Hello, fellow humans. Top energy experts say it's too late for renewables, and zero carbon is a highly unlikely outcome. A data scientist working for Our World in Data writes that it's not the end of the world. What is going on? How does the world really work? Are we going to blow up the planet into pieces? Is civilization going to collapse because humans are self-destructive by nature? Or are we going to be fine with a bit of global heating here and there, some mass starvation of the poorest humans, and some extinction of species? I'm going to look at many facts, interpret what they say, and also what they don't say. Numbers don't lie, writes one famous energy expert. Of course they don't lie, they're numbers. They don't have a brain and a mouth. But humans using numbers can lie by not talking about all numbers, by leaving out the context of the numbers, by leaving out all the interpretations of the numbers, and by misleading about the implications and solutions that can be drawn from numbers. Let's see how the world really works. A joule is a measure of the energy required to send an electrical current of 1 ampere through a resistance of 1 ohm for 1 second. A gigajoule is 1 billion joules. 1 gigajoule is equal to 277.8 kilowatt hours or 0.17 barrels of oil. Burning 1 million wooden matches completely at one time releases 1 gigajoule of energy. 1 gigajoule of electricity could make 1,000 pots of coffee or keep a 60-watt light bulb continuously lit for 6 months. Gigajoules are helpful to measure and compare energy from different types of power, such as electricity, natural gas, and oil. Similar to equivalent kilowatt hours, 1 gigajoule provides a standard measurement that lets you calculate a single energy intensity figure, a number you can then use to compare with those of other facilities. To convert from kilowatt hour to gigajoule, multiply by 0.0036. To convert gigajoule to kilowatt hour, multiply by 277.8. Energy density is the amount of energy that can be stored in a given system, substance, or region of space. Energy density can be measured in energy per volume or per mass. The higher the energy density of a system or material, the greater the amount of energy it has stored. Wood has an energy density of 16 megajoules per kilogram. Lithium is 43 megajoules per kilogram. Crude oil has 44 megajoules per kilogram. Uranium-235 has 3,900,000 megajoules per kilogram. Turbofan engines powering jetliners burn kerosene with an energy density of 43 megajoules per kilogram, or about 12,000 watt-hours per kilogram. Best lithium-ion batteries supply less than 300 watt-hours per kilogram. Electric motors are twice as efficient energy converters as gas turbines, which means the real density gap is only about 20 times. To get to 12,000 watt-hours per kilogram density for batteries, up from 300 today, by 2050 is impossible. That's why we won't have electric planes anytime soon. In 2018, the proportion of people from high-income countries that fly at least once a year was 40%, compared to only 0.7% of people from low-income countries. In 2019, aviation was responsible for the emissions of 920 million tons of CO2, a 30% increase from 2013. Only 11% of the world's population travels by air, with around 4% flying internationally. Between 2013 and 2019, air traffic increased 4 times faster than fuel efficiency. In other words, if we don't eliminate this inequality in flying, and if we do not fly much less in the rich countries, we will not reduce emissions from aviation. This is called degrowth. What about China? Fossil fuels in China fell from 93% in the year 2000 to 85% in 2019 as share of their primary energy supply. At the same time, demand for fossil fuels tripled. Because of China, global consumption of fossil fuels increased 45% during the first 2 decades of the 21st century. Annual global demand for fossil carbon is about 10 billion tons a year, almost 5 times more than the annual harvest of all staple grains that feed humanity, more than twice the total mass of water drunk annually by all humans. China is the #1 exporter in the world. In 2022, its GDP was $17.88 trillion against total exports of $3.73 trillion, with electrical machinery and electronics leading at almost 30%. Those exports went to these countries: US 14.8%, Japan 4.76%, Germany 4.07%, and so on. If we do basic math, is it fair to say that 3% of all Chinese emissions are made to manufacture products that end up in the United States? Should those emissions count for China or for the US? And how much of that production is to benefit fast fashion and fast consumption outside China? We should talk about how that production is made. All of the following is also happening in China. 5.7 million people live in modern slavery. Ultra-fast fashion brand Shein exploits workers to get you to buy more. Car companies are complicit in forced labor. The government controls behavior through social credit in a twisted Orwellian experiment. Talking about the material and energy throughput in the economy is half of the story. We must also talk about the human experience, well-being, quality of life, and freedom that is not directly linked to the size of the GDP. Some energy experts say it is too late for renewables and we cannot phase out fossil fuels by 2050. And that is very much true under the current status quo, which is the global capitalist mode of production and consumption. In 2019, the world consumed 4.5 billion tons of cement, 1.8 billion tons of steel, 370 million tons of plastics, and 150 million tons of ammonia. These are not easily replaceable by other materials. Global production of these 4 indispensable materials claim about 17% of the world's primary energy supply and 25% of all CO2 emissions originating in the combustion of fossil fuels. Some experts argue we cannot have a civilization without these materials. Take ammonia. In 2020, nearly 4 billion people would not have been alive without synthetic ammonia. About 80% of global ammonia production is used to fertilize crops. The rest is used to make nitric acid, explosives, rocket propellants, dyes, fibers, window and floor cleaners. With proper precautions and special equipment, ammonia can be applied directly to fields, but the compound is mostly used as the indispensable feedstock for producing solid and liquid nitrogenous fertilizers. About 150 megatons of ammonia are now synthesized annually, with about 80% used as fertilizer. Nearly 60% of that fertilizer is applied in Asia, about a quarter in Europe and North America, and less than 5% in Africa. Rich countries should pull back on their high application rates. Even China and India, 2 very heavy users, have many opportunities to reduce their excessive fertilizer applications. It seems that ammonia is the only way to do agriculture and feed the world, if we listen to this data. There's more to the story if one cares enough to investigate. A study led by the Indian Council of Agricultural Research shows that the nutritional value of crops has decreased by up to 45% in the past 50 years or so. This is linked also to the intensive use of synthetic fertilizers. And of course, it feels we must use ammonia and synthetic fertilizers if we ignore the alternatives. I talked before in some detail about how capitalism ruins food for profit, and I talked about solutions. Agroecology can feed the world of 8 and 10 billion people. Farms less than 2 hectares produce 28-31% of total crop production and 34% of the global food supply. Their contribution is slightly higher than their aerial coverage of 24% of gross harvested area, suggesting small farmers have greater cropping intensity or higher yields than larger farms. Whatever Monsanto, Bayer, BASF, Syngenta are doing is much more for capital accumulation than to actually feed the world with healthy food out of the goodness of their hearts. Saying we are so dependent on ammonia or synthetic fertilizers, we cannot phase them out, is defeatist at best and manipulative by omission at the least. This thinking assumes the current mode of production, which is feeding the world with higher yield but less quality crops, is the only game in town. At the same time, the industrial mode of production is burning the planet and destroying biodiversity. Do we really have to choose between eating and losing the environment? Of course not. We must ditch the status quo, the extractivist and imperialist mode of production that created this crisis. With degrowth, we can phase out industrial agriculture and phase in agroecology with democratic modes of production. Plastics are synthetic or semi-synthetic organic materials that are fit for molding into shapes. Synthesis of plastics begins with monomers, which are simple molecules that are bonded in chains to make polymers. Two key monomers, ethylene and propylene, are produced by steam cracking, which is the heating of hydrocarbon feedstocks up to 950 degrees Celsius. The global output has been dominated by thermoplastics, which are polymers that soften when heated and harden again when cooled. Polyethylene, PE, accounts for more than 20% of the world's plastics polymers. Polypropylene, PP, for about 15%, and polyvinyl chloride, PVC, for more than 10%. By the end of the 20th century, we had 50 different kinds of plastics. The global production of PE, PP, PVC, and PET increased from 20,000 tons in 1925 to 2 million tons by 1950, 100 million tons by the year 2000, and about 370 million tons by 2019. They come in combinations of low weight and high hardness. Durable aluminum weighs a third as much as carbon steel, but PVC density is less than 20% and PPP less than 12% compared to steel. The tensile strength of structural steel is 400 megapascals. Polystyrene is at 100 megapascals, which is twice that of wood and glass, and only 10% less than that of aluminum. Plastics are awesome, so it seems. Did demand from consumers create 50 kinds of plastics? Or was it the simple quest for profit? While many plastics are essential for medical equipment, for research and education, for consumer electronics, we are also choking on plastics as a civilization. We live in a platisphere. Around the world, 1 million plastic bottles are purchased every minute, while up to 5 trillion plastic bags are used worldwide every year. In total, half of all plastic produced is designed for single-use purposes, used just once and then thrown away. Today, we produce about 400 million tons of plastic waste every year. 1,000 rivers are accountable for nearly 80% of global annual riverine plastic emissions into the ocean, which range between 0.8 and 2.7 million tons per year. 74% of the litter cataloged in pilot sites along the Mississippi River is plastic. China mismanages 74% of its plastics. India mismanages 80% of its plastics. We hear the sustainability class begging everyone to become a zero-waste champion, invest in sustainable ocean-friendly products, reusable coffee mugs, water bottles, and food wraps. Awesome! Wow! While the experts give us raw data about how much plastics we produce, how dependent we are on plastics, how we cannot make plastics without fossil fuels, we have lifestyle environmentalists putting the responsibility on consumers and individual behavior, while in reality the bigger picture is about manufacturing need through manipulative advertising, about rapacious capital accumulation, about proselytizing neoliberalism. If we need plastic for medical equipment, let's make it the best we can, until we invent new materials that do not destroy the environment. At the same time, we drastically reduce production and consumption of stupid single-use objects and make manufacturers responsible for the full life cycle of their products. In other words, degrowth. Iron making is very energy intensive. 75% of the total demand for iron is claimed by blast furnaces. The best practices of making iron have a combined demand of 1720 gigajoules per ton of finished product. However, the energy cost of secondary steel made in electric arc furnaces is just above 2 gigajoules per ton at best performance. But if you have to add the energy cost of rolling the metal, another 1.5 to 2 gigajoules per ton. This makes overall energy cost at about 25 gigajoules per ton for integrated steelmaking and 5 gigajoules per ton for steel required by electric arc furnaces. The total energy requirement of global steel production in 2019 was about 34 exajoules, which is 6% of the world's primary energy supply. We need steel. We cannot live without steel. However, we cannot make it 100% in electric arc furnaces with non-fossil primary energy sources. The technology does not exist yet. If we want to build high-density urban areas, highways, bridges, cars, trucks, shipping containers, and casinos, steel is a must-have ingredient. The question becomes, how much urban density is the right kind of density? How many personal cars do we need as opposed to public transit? How many shipping containers? How many casinos? It becomes a question of quantity because the question of quality cannot be answered fast enough to keep global heating within planetary boundaries. We could produce much less steel if we all use public transit, bought much less from Amazon and AliExpress, and lived in smaller houses. All of that requires the overhaul of the system. Cement is much less energy intensive than steel, but its global output is 3 times that of steel. This makes the production of cement similar to the production of steel at about 8% of emitted carbon. In just 2 years, 2018 and 2019, China produced almost as much cement, 4.4 billion tons, as did the United States during the entire 20th century at 4.56 billion tons. China now has the world's most extensive systems of freeways, rapid trains, airports, the most giant hydro stations, and multi-million population cities. The world now consumes in 1 year more cement than it did during the entire first half of the 20th century. When population grows, suddenly that population needs to live somewhere. They either live together by choice or by poverty, or they search to live in a newly constructed building. All that new construction in poor countries where most of the population growth is happening, if it replicated the post-1990 Chinese experience, would require more than 10 times boost for cement production. This is on top of the 15 times increase for steel production, double for ammonia, and 30 times increase for plastics. Research shows that the growth of the material throughput in the economy has not decoupled from carbon emissions and cannot decouple fast enough to avoid global warming. Books like Housing for Degrowth are asking the most fundamental questions, such as, Is urban sprawl a good thing? No, it's not. Can we all move into eco-villages with houses made from sustainable materials? No, we cannot. Are high-rise, high-density buildings fully sustainable? It depends. Do we need more highways and more roads? No, in the global north. Yes, in the global south. Do we need more trains that do not need that much concrete, except for train stations, tunnels, and bridges? Yes, everywhere. In any case, concrete with its emissions will not go away by 2050. Electric cars have an enormous appetite for materials. Supplying these materials for one vehicle requires the extraction and processing of about 225 tons of raw materials. If you want to replace the annual global production of internal combustion vehicles with electric drive, you would need to multiply that by 100+ million to get the requirement for raw materials. SUVs emit annually about 25% more CO2 than a standard car. SUVs are the second highest cause of rising CO2 emissions, behind electricity generation and ahead of heavy industry, trucking and aviation. 250 million SUVs on the road compared to 10 million electric vehicles in 2020 completely obliterate all chances of zero emissions by 2050. Thinking of a car as an object that moves our bodies to another place is better than thinking of a car as a symbol for status and vehicle for patronizing arrogance. This study shows that scenarios that reduce car dependency, use and ownership with limited battery size for electric vehicles can lower the demand for lithium between 18 and 66%, even if the car centricity of the United States transportation system continues. Limiting the size of EV batteries can cut lithium demand by as much as 42%. Portland has more than 800 cars per 1,000 residents, and about 80% of trips are by private vehicle. This is not a question about consumers deciding what to buy. It is entirely a matter of production and infrastructure. The decisions to make large cars belong entirely to the capital-owning class. The decisions to expand public transportation belong entirely to government. If given the choice, people would opt for convenient public transit instead of personal ownership of vehicles that gets them stuck in traffic. For a 5-megawatt turbine, the steel alone averages 150 tons for the reinforced concrete foundations, 250 tons for the rotor hubs and nacelles, and 500 tons for the towers. If wind-generated electricity were to supply 25% of global demand by 2030, then even with a high average capacity factor of 35%, the aggregate installed wind power of about 2.5 terawatts would require roughly 450 million tons of steel. To make the steel required for wind turbines that might operate by 2030, you would need fossil fuels equivalent to more than 600 million tons of coal. And when all this is in place, the entire structure must be waterproofed with resins whose synthesis starts with ethylene. Yet another required oil product is lubricant for the turbine gearboxes, which has to be changed periodically during the machine's 2-decade lifetime. Windmills, solar panels, heat pumps, pumped hydro, all tech has an environmental footprint. Yet we cannot have a civilization without energy. Even solar has its problems because sometimes the sun doesn't shine, and batteries used for storing solar energy are also problematic. Nuclear power has life cycle emissions of about 6 grams of CO2 per kilowatt hour compared to wind at 8 to 23 and coal of up to 1095. Of course, see the fine print for details. Many people find windmills beautiful and love them the most when they are not in their backyard. The same can be said about solar. Nuclear, however, even if it looks good on paper as an energy source, still suffers from historical stigma, considering the few accidents that tarnished its reputation. The questions, yet again, are about who uses this energy and how much of it. Can we really have a civilization by using much less energy? The definite answer is yes, we can. Despite population growth, global energy use could be reduced to 1960 levels. We can live decently with 18 gigajoules per person per year. Decent living energy estimates all lie within the narrow green band, where the dark line is the global mean. The red dots are surpluses that we can do without, and the blue dots are folks that deserve more energy in their lives. Rich countries consume annually about 150 gigajoules of primary energy per person per year. For comparison, 1 ton of crude oil is 42 gigajoules. Nigeria, the most populous country and most rich in oil and natural gas in Africa, averages 35 gigajoules per person per year. This is in stark positive correlation with the greenhouse gas emissions. North America and Europe combined generate 49% of total emissions, China 11%, Sub-Saharan Africa 4%, 53 billion tons against a remaining budget of 200 billion tons for a 1.5 degrees Celsius warming scenario until 2029. What is all that energy for? Consumption and profit. On the consumption side, rich countries, also known as the global north, take resources worth between $2 and $3 trillion every year from the global south. All that wealth is effectively stolen from the south, so consumerism can exist in the north. This is why the south cannot develop. It is prevented from doing so through what is known as unequal exchange in the global trade, a perfectly legal system of plunder that is the backbone of capitalism. If we look at the profit side, $1 trillion are moved to tax havens every year. This is the equivalent of 35% of all profits booked by multinational companies outside of their headquarter country. At the same time, the wealth of all billionaires is about $13 trillion. These are staggering amounts. The fact that 1.1% of all humans own 45.8% of all wealth is possible because capitalism can only function with inequality and accumulation of wealth. If we put a limit on wealth at $10 million, as I've discussed here, and if we limited consumption of energy and materials to provide for decent living, but not luxurious living, which means a limit of 18 gigajoules per person per year, if we did all that, we will be able to eliminate all poverty, slow down the ecological collapse and even reverse it, and increase happiness and well-being for everyone. Václav Smil writes in a report for Fraser Institute, a known member of the nefarious Atlas Network, no natural laws bar us from making the enormous investments needed to sustain such massive annual shifts. We could resort to an unprecedented, decades-long and civilization-wide existential mobilization of constructive and transformative efforts, or conversely, we could deliberately reduce our energy use by lowering our standard of living and keeping it low to make it easier to displace all fossil carbon. In less words, this translates into green growth versus degrowth. When these two concepts come into a debate, degrowth wins every single time, which is extremely inconvenient for capitalism. Green growth has been debunked over and over again, which means that if we read the data from experts, the sensible conclusion is that we must phase out capitalism by using degrowth to create a new economic system that is not based on capital accumulation for its own sake, a system that looks at meeting genuine human needs with a thoughtful, scientific, egalitarian, holistic understanding of well-being. We can innovate and increase efficiency of energy and materials until we are red in the face, or should we say green in the face. But if we do not dismantle the strong connection between the regimes of private property, the regimes of corporate power, and the methods by which capital is incorporated into the means of production, while also phasing out the profit motive, if these do not happen, surely the energy experts will be proven correct. Business as usual will continue. Warming will get to 2 degrees Celsius. Social unrest will erupt around the world. Quick takeaways about facts and truth. Trust data if it comes from recognized scientific sources, but always triple check. Don't just go to ourworldindata.org or visualcapitalist.com or statista.com. Check if other peer-reviewed sources say the same thing. Question data that maintains the status quo of capitalism, especially if it comes from a member of the Atlas network. Always ask what is missing from the bigger picture. Who has the power? Who owns everything, including the means of production? What is capital made of? If data doesn't talk about all these 3 elements, it is incomplete data. And finally, a quote for your t-shirt. Data is not truth, but truth needs data. If you can, please support me through the links below to cover the cost of these videos. Future videos will not be possible without your support. I will never collect money from advertising. Until next time, be well, increase the peace.